Hi, Algebra 2 Honor students. This is going to be Algebra Review Day 3. We're going to talk about solving absolute value equations today. So if you want to take out some paper so we can take some notes by hand, that would be fantastic. So when thinking about how we solve absolute value equations, today our focus is going to be primarily on the solution techniques that we can use algebraically. But before we get into the algebraic side of things, we are going to take a look at graphically what y equals the absolute value of x looks like. This might be something you're familiar with from Algebra 1. But if you don't quite remember, the easiest way to figure out what the graph of an equation looks like is to make a table of values. So as you're getting set up in your notes here, you can see that off to the side here, I have a table where the x values go from -2 to 2. That's usually a good place to start, if you're not sure what something looks like, and then you can always adjust your table from there. But I'm going to do this by hand just so we can kind of think about this analytically today. And then by tomorrow's lesson, we'll be really looking at using the graphing calculator a little bit more to generate some graphs as well. So if we think about the absolute value function, what we should remember is that when you take the absolute value of a quantity, it basically takes anything that's negative and makes it positive. And as a quick reminder as to why, absolute value by definition is the distance this value is from 0. So we say the absolute value of -2 is +2 because it's 2 units. Its distance from 0 is 2. All right, absolute value of -1 would therefore be 1, and then anything 0 or positive is going to return the same value. So we have this list of x and y values. If I were to start plotting this, just to get an idea of what the graph looks like, we would have -2, 2, and -1, 1, and 0, 0. And then it would turn around and start heading back up again, 1, 1, and 2, 2. And what that does for us is it creates this V-shaped looking graph. So even if you didn't remember exactly what it looked like, maybe you're now recalling that the absolute value of x does tend to have this V-shaped graph to it. So what I want us to do is see if we can, using our knowledge of what the graph of absolute value of x looks like, let's see if we can take a look at solving these equations real quick. So if I have absolute value of x equals 3, and I want to solve this equation, well, I may not come up with the answers right away, but let's at least graph it and see what is this going to look like. The absolute value of x, we know, is that V shape. And you don't need anything super specific. I would like you to get some graph paper as part of your binder of loose leaf and note packets and things like that, because there are times this year that we'll just be taking notes with graph paper and things of that nature. So I don't think we need it exactly for this right now. I want to know, when would I input something for x such that the output would be 3? And when I talk about an output, I'm talking about a y value. So a y value of 3 might be like right about there. And you'll notice that the absolute value of x equaling 3 has 2 solutions. And I bet you know what those 2 solutions are, but I want to hold off on that for now. We do know that, though, this has 2 answers. So sometimes you'll solve an absolute value equation and get those 2 answers. In other instances, like absolute value of x equals 0, again, you might want to sketch a quick V shape for the absolute value of x. But what I think you'll see quickly happen here is when I draw on the line y equals 0, which is basically just the x-axis, we get that it's only going to touch at that one point. That one point is known as the vertex of the graph. So this is a case where we only have one solution. And in the last scenario, as you become accustomed to solving equations algebraically, you might be familiar with cases of absolute value or other graphs that may not have any solution at all, because look at where the output of -2 would be. It would be anything along this line right here. So there are certainly times where I say, hey, let's solve the equation, and the turnout from that is that we have no solutions at all. So the question becomes, for this, which is a pretty simple case because it's just the input of x there in the absolute value function, how would I solve this algebraically? Okay, so to solve the equation in part A algebraically, we have to consider the following. So I'll give you a second to kind of maybe copy that part down. But while you're copying this piece to solve that equation algebraically, what do we have to consider? What we really have to consider is that an absolute value function is essentially a combination of 2 different linear functions. And those 2 linear functions meet at this vertex point. So if I wanted to know the solution on, let's say, the right-hand side, the positive side of the x-axis, this line right here is the line y equals x. So what I want to know, what we have to consider is, where does, well, it's not going to be able to solve, but one of the solutions is that x equals 3. Or on the other hand, the line that's over here is the line y equals negative x. So what we have to do on the other side is say, when does the line y equals negative x equal 3? And there's just one quick step, right? Divide out -1 on both sides, and we get that the other solution is x equals -3. So those are the two solutions to that equation. I'm pretty sure we knew those just based on the graph to begin with. But if the equation becomes more complicated, what steps can we follow algebraically to get these solutions? And it's going to be exactly what we just did. Keep what's in the absolute value the same, set it equal to 3. And then on the other hand, negate what's on the inside of the absolute value, because that's what we're seeing on the other side of the V shape. And then set that equal to 3 and solve. So if we use that logic here are some quick steps that we can use to solve absolute value equations algebraically. First thing is to isolate the absolute value expression. So if there's a coefficient being multiplied on the outside, if we have an absolute value plus a number afterwards, you want to do some algebra to isolate your absolute value expression. Step 2, then, once it's isolated, split it into 2 equations, which we kind of saw a little bit of here. One where you take the quantity on the inside and leave it as is, and then the other case where we negate that quantity, like here. So that's what I kind of said here. When you split into 2 equations, the first equation stays the same without the absolute value bars. In the second instance, you need to negate the absolute value side. And then finally, you need to solve, and not only solve, but also check your answers. I mean, checking is a pretty important part of the process in general when you're solving equations. But specifically, we know that if we don't check, we may wind up getting some answers that turn out to not really be answers at all. Maybe it's that 0 solutions case. So I'll tell you the algebraic way of solving this, you're going to get 2 answers no matter what. But upon checking those answers, you may find that there was no solution to begin with. And we'll reference that a little bit more when we get into some solving cases. Okay. Let's go ahead and take a look at some practice of these. So if I take a look at number 1 here, the absolute value of 3x plus 2 is equal to 8. Our first step says to isolate the absolute value expression. So I would do this by subtracting 2 from both sides. I probably will almost never show that step again. It's nice to write subtract 2 from both sides just to kind of keep things balanced here. But if I'm being completely honest, when you get into upper level algebra, you're just going to see this written as the next step. Absolute value of 3x equals 6. So what do I do now that I've isolated the absolute value expression? Now we're going to split this into 2 equations. So I usually, for absolute value, will kind of draw 2 branches. And on one branch, we're going to solve when does 3x equal 6. And the other branch, we're going to solve when does negative 3x equal 6. And then this is going to be a pretty quick solve from here. If you divide both sides by 3, you get x equals 2 in this case. Divide both sides by -3. On this side, we would get x equals -2. To save some time, I'll show you what the check looks like just for one of these values. I think students sometimes get scared of negative answers, so I'll check x equals -2. It would be the absolute value of 3 times -2 plus 2, and does that equal 8? Well, 3 times -2 is -6. So the absolute value of -6 is +6 plus 2. Yep, that in fact does check out to give you an answer of 8. In theory, I guess it would be great if you check both answers at all times just to make sure they both work. For absolute value, if one works, probably the other one's going to work as well. Okay. All right, let's move on to number 2 there. So number 2, it's a little bit more to isolate that absolute value expression. So we have that -2 on the outside. We also have to contend with being multiplied by 3. So if we're following, the logical steps of solving an equation, let's add the 2 over first. So 3 times the absolute value of 4x minus 5 now equals 21. And then to isolate one more step beyond that, divide both sides by 3. Absolute value of 4x minus 5 now equals 7. Now it looks just like the case that we had over here. We've isolated the absolute value. And we can now split this into 2 different equations. So on one side, we get 4x minus 5 is equal to 7. That's the easy one to write. Just drop those absolute value bars. But in the other scenario, here's where it's going to look a little bit different than number one. You have to negate the entire expression for x minus 5. And set that equal to 7. So realize that what that does, if you don't write it this way every single time, is it negates both of those terms. If I distribute that negative in. On this side of the branch, I'm going to solve when does negative 4x plus 5 equal 7. So be cautious that when you make that split, you change the sign of both terms there. You can write that initially as putting the negative outside that entire expression if you want. Let me keep solving that. So if I subtract the 5 over, I get negative 4x is equal to 2. And negative 2/4 would reduce to an answer of negative 1/2. So that's one answer here. On the other side, we'll add 5 over. So 4x equals 12. And therefore, x equals 3. So those are my two answers. Hopefully, you'll just trust me for now that those do check out. If you go ahead and check them, plug them back in, make sure that they work. All right, we've got 2 more to look at here. And then next time I see you, we'll do a little bit more practice with this in class. But the first thing I'm going to do for number 3 is subtract that 20 to the other side. So 4 times the absolute value of w minus 6 is going to equal negative 12. Right, so take those steps to isolate the absolute value expression. Then I'm going to divide both sides by 4 to get that the absolute value of w minus 6 is equal to negative 3. And I'll tell you that this is the stage where we would typically stop and split our branches up. However, I'm going to make a big deal here and stop and ask you, does it make any logical sense that no matter what I input for w, if I take the absolute value of this expression, will it equal negative 3 ever? And the answer to that is no. It's impossible to take the absolute value of something and get a negative result. So I know once I've isolated the absolute value, if there is a negative on the other side of the equation, you can stop right there and say no solution. Even if this were on a test, if you did those initial steps to isolate the absolute value and then stopped yourself and said no solution, I would be fine with that. This is enough work to show me that you understand that stopping here means this is not possible. But what if I continued? What if I had said, oops, I didn't see that. Let me split it to w minus 6 equals negative 3. And then the other side of the equation would be negative w plus 6, right? Change both of those signs, equals negative 3. It's pretty misleading because you're going to add 6 over, get w equals 3. Here you're going to subtract 6 over to make that a negative 9. But dividing out negative 1 makes it positive 9. And I think, yeah, those look like lovely answers. W equals 3, W equals 9. Why not, right? All right, let's just check one of them to see what happens. So for the check of 3, it would be 20 plus 4 times absolute value of 3 minus 6. And does that equal 8? This is why the check is pretty critical, because it's really easy to not see this here and say no solution and just constantly think, oh, split it and keep going. All right, so this is going to be 20 plus 4 times the absolute value of negative 3. Absolute value of negative 3 is positive 3, so if you're okay with that, I'm just going to write that as a 12. And then 20 plus 12 is 32. So yeah, that doesn't work. And if you check w equals 9, you'll get the same result. Tomorrow we'll start confirming graphically why that's the case, but for now, algebraically, this is what you have to look for. Absolute value by itself equals a negative, definitely no solution. The check will help you to confirm some of those things. So don't forget to throw that in when needed. All right, let's finish up with number 4. In fact, I would encourage you to hit pause at this point, write that down in your notes, try it on your own, see where you're at. I'm going to go through the solution right now, but if you want to give this one a shot, go ahead and try it, and then hit unpause in just a moment. All right, I'm going to start by subtracting 5 to the other side. So I get negative 2 absolute value of 3x minus 6 equals negative 6. And if I stop here and I'm like, oh, absolute value equals negative, that means no solution, I can't do that yet. The absolute value has to be completely isolated before you make that conclusion. So divide out the negative 2 on both sides, and what we'll see is that this will have solutions, because now I get absolute value of 3x minus 6 is equal to 3. So now we can split it up into 2 equations. We get 3x minus 6 equals 3. We get negative 3x plus 6 equals 3. Negate the whole expression in there. And then continue to solve. Here, 3x equals 9. So x equals 3 should be one solution. I'll let you do the check. Negative 3x over here is going to equal negative 3. So x will also equal positive 1. And those would be the two solutions to that equation. So if you have any questions at all, you'll let me know the next day in class. Reach out to me. Otherwise, we'll do a little bit more practice with this and then get to some graphical situations next time I see you. Have a good one.